Ed Excel, PU Mathematics, Paper 2, Advanced Level 9MA, June 2018. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. Question number 1. Find G of 5. And part B, state the range of G. So for part A, we want to find G of 5. So we first of all do the one in front. We want to get G of 5. The one in front is the one we do first. So we take this 5 and put it in there and put it in there. So that means G of 5 would be 2 times 5 plus 5 divided by 5 minus 3. That gives you 7.5. Now we take that answer 7.5. To get the second G, it will be the second G of 7.5. So we take that 7.5 and we put it in there for X. So that 7.5 goes there and it goes there. So it's G 2 times 7.5 plus 5 over 7.5 minus 5. That gives you 49 over 4 or 4.4 recurring. For part B, we want the range. The range starts from 2 and ends at 15 over 2. And since X is bigger than or equals to 5, we can substitute the 5 for X and substitute the 5 for X, and that gives us 15 over 2. Another way to do part of it is to hide y equals to 2x plus 5 over x minus 2. You make it equals to y, and then you want to make x the subject. So x minus 3 goes to the left. It becomes y bracket x minus 3 equals to 2x plus 5. Remove the bracket. You get yx minus 3y equals to 2x plus 5. And you collect like terms. 2x comes to the left, becomes minus 2x. And 3y goes to the right, becomes plus 3y. So you factorize x bracket y minus 2 is equals to 5 plus 3y, and you get x to be 5 plus 3y over y minus 2. And you want the denominator, the value that will make it 0. So if y minus 2 equals to 0, y equals to 2. And that is how we get that 2 there and that 15 over 2. You can also use your graphics calculator to plot the function y equals to 2x plus 5 over x minus 3. And you would look here, and the range is what is on the y-axis. And that's the y-axis. So you look here, it goes, the smallest value is that 2 there. That's why it starts at 2. And the biggest value is this here, which is 7.5, which is 15 over 2. So that's why the range is from 2 up to 15 over 2. And when you put the graph in your graphics calculator, use this value for x minimum, for x maximum, y minimum, y maximum, so that you can see it clearly. You can see the whole graph in the calculator. And also, if you go from minus 20 up to 20, minus 20 in the x-axis, up to 20 in the x-axis, and the range, so minus 20 in the x-axis up to 20 in the x-axis, from minus 30 in the y-axis up to 50 in the y-axis, you will see a complete graph. So for part C, we write y equals to 2x plus 5 over x minus 3. So we write this as y. And then we can swap x and y. So wherever we see x, we can swap x and y. So we swap x and y. So y is equals to 5 plus 3x over x minus 2. And if you have y equals to 3x plus 5 over x minus 2, so g inverse of x is 3x plus 5 over x minus 2. And the domain is from 2 to 15 over 2. And domain for the inverse, for G inverse, is the range for G. So the domain for G inverse is the range for G. Question number 2. Relative to a fixed origin O, the point A has position vector. Part A, find the position vector of D. And part B, find the value of A. AB is equals to BD. But AB is OB minus OA. Remember, it's the second letter minus the first letter. So to go from A to B, you get O to B minus O to A. To go from B to D, it's O to D minus O to B. And from equation 2, we can have O to D is the same as B to D plus O to B. So we take minus O to B to this side, it becomes plus. So it becomes plus OB. And O to D now is AB plus OB, which is what you're going to use. So it's very important to follow this clearly. So now O to D is AB, because AB is the same as BD. So AB is the same as BD. So that is why it would be AB plus OB. So you got OA is there, OB is there, OC is there. Now AB is OB minus OA, the second letter minus the first. So to get AB, that's OB and OA. So 4 minus 2, it gives you 2. Minus 2 minus 3, it gives you minus 5. And 3 minus minus 4, it gives you 7. So your OD is AB, which is the one we found there. So we've got AB there, plus OB, which is, that's OB. 2 plus 4, 6. Minus 5 plus minus 2, minus 7. 7 plus 3 is 10. You can write it with I and J. So this is 6I minus 7J plus 10K. For question 2B, AC is equals to 4. So to go from A to C, you go OC minus OA. Remember the second letter minus the first one. Remember that. OC is A5 minus 2 and OA is 2, 3 minus 4. So A minus 2, 5 minus 3 is 2, minus 2 minus minus 4. This minus and minus becomes a plus. It becomes 4 minus 2, which is 2. To find the magnitude of AC, A minus 2 squared, which is A minus 2 times A minus 2, plus 2 squared, plus 2 squared. So A minus 2 squared is A squared minus 4A plus 4. 2 squared is 4. 2 squared is 4. And 4 squared there. So you want to, 4 squared will go cancel when you start to subtract. So you end up with A squared minus 4a minus 4 is equal to 0. Because 4 squared is 16. 4 plus 4 plus 4 is 12. 16 minus 12 is 4. And that's why you got the 4 there. Now you can use your calculator. You will get a to be 2 plus 2 root 2 and a to be 2 minus 2 root 2. But as a is less than 0, we will use a is equals to 2 minus 2 root 2. Question number 3. If m and n are irrational numbers where m is not equal to n, then mn is also irrational. Disprove this statement by means of a counter example. Remember, when you want to disprove a statement by a counter example, just one example is enough to disprove it. So all you need to do is to find out one example. You don't need to do lots of them. So if m and n are irrational, you got to know what irrational numbers are and what. So for example, if we use square root of 3 as one irrational number and square root of 12 as one irrational number. Now, when you multiply them, so m is there and n is there, you multiply m times n, square root of 3 times square root of 12. What does that give you? Put it in your calculator, you get 6. Or you can just do it as 12 times 3 and then square root, which is square root of 36, which is 6. You get 6. And you can say the statement is untrue because 6 is not irrational. 6 is not irrational. 6 is rational. So you've given one example of where it is not correct. You use one irrational number and another irrational, multiply them to get a rational number. I've put here below some of the things that I see some students tend to ask because students are not sure about numbers, the types of numbers. You can divide numbers into two groups, just like you can divide male humans into male and female. So if you have humans, you can divide humans into male and female. So we can divide numbers into real and imaginary. And imaginary will have roots of negative numbers, which we use I. But when we come to real numbers, we can divide real numbers again into rational and irrational. Irrational will be things like root 2 and pi. And the irrational will be those ones that example of that root 3, root 12. And under rational numbers, you can divide them into fractions and integers. Fractions will be like half, 3 over 4. Integers will be minus 3, minus 2, minus 1, 0, 1, 2, 3. And then after that, you could divide integers. Integers will have just whole numbers, like the 0 numbers, 0, 1, 2, 3. And then after that, we can have natural numbers. That's the numbers we count, 1, 2, 3, 4, 5. Into this is all just other subdivisions, but it just gives you an idea how you divide numbers. Real, imaginary. You use imaginary for those who do further maths. Under the real, there's rational, irrational. For question 3b, sketch the graph of y equals to absolute value of x plus 3. When you sketch the graph, you will see this blue one there. That's the first graph, absolute value of x plus 3. Use your calculator. The graph should be a V shape. That's what will give you a mark. And it has to be symmetrical about the y-axis. That means you put the y-axis in the middle. The right side should be the same like the left side. That's what's symmetrical. And it has to be a V shape. Very important. And you also have to mark where it crosses the y-axis, 0, 3. Very, very important. That's what gives you the mark. And that covers part 1. For part 2, you need to explain why x plus 3 is greater than or equals for all real values of x. You can plot the other one, x plus 3. second graph. I've put it there. It starts with you see the yellow part there. That's part of that graph. Your graphics calculator will do that for you. Now, you mark where it touches the x-axis. So what you do, you superimpose the graph of y equals x plus 3 on top of the graph of y equals to absolute value of x plus 3. And you can see the part I've colored in yellow. That part there is below. So the graph of y equals to absolute value of x plus 3 is either the same or above the graph of y equals x plus 3 for corresponding values of x. So this is the first one. From x greater than or equals to 0, if you start from this point here, x greater than or equals to 0, the two graphs are the same. See, the two graphs are the same. They are equal when you start from x is equal to 0. So you can see the two of them go up that way, they go up that way. So from x equals to 0, the two graphs are the same. So you will write x plus 3, absolute value of x plus 3 is equal to absolute value of x plus 3. Now, but when x is less than 0, below 0, the one in yellow, the graph in yellow is below the graph in blue. So that means x plus 3 is less than the other one, or you can say absolute value of x is greater than absolute value of x plus 1. So below 0, when x is less than 0, the blue graph is greater than the yellow graph. And you can write it like that in the symbol form. Question number 4. Show that sum from r is equals to 1 to 16 is equals to 131,798. So to do question 4i, we would separate it. We would have it as sum from r equals to 1 to 16, 3. Sum from r equals to 1 to 16, 5r. And sum from r equals to 1 to 16, 2 to the r. So that's very important. You separate it. Because we are adding them, we are separating them to make it easier to manipulate. So for the first one, from r equals to 1 to 16, it's just the same as 3 times 16. Because it's like writing 3 16 times. 3 plus 3 plus 3 plus 3 plus 3, 16 times. So you just do 3 times 16 for the first one. For the second, sum from r equals to 1 to 16, 5r. So we start with r equals to 1. So 5 times 1 is equals to 5. R is 2. 5 times 2. 5 times 2 is 10. R is 3. That's 5 times 3 is 15. We're going up to 16. And when we do that, we get to R equals to 5. It gets 25. We notice that the sequence is going, you add 5. 5 plus 5 gives 10. 10 plus 5 gives 15. 15 plus 5 gives 20. So it's an arithmetic sequence. So in an exam, you don't have to do it 16 times and then you add them up. That would take you a very long time. So what you do, you use the formula for n term of an arithmetic sequence. This formula, you get it in the formula book. I put it in there. So n is 16 because there are 16 numbers. The a is the first one is 5. And d, the difference is 5 because 10 minus 5 is 5. 15 minus 10 is 5. You put those numbers, n is 16, a is 5, d is 5. You put in your calculator and you will get the final answer, 680. For the last one, 2 to the power r. So when r is 1, 2 to the 1 is 2. When r is 2, 2 to the 2 is 4. When r is 3, put 2 to the 3 is 8. When r is 4, 2 to the 4, 2 to the 4 there is 16. And this one is going up, like 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. So the common ratio is 2. First term is 2, and this is a geometric sequence. So you use this formula for sum of geometric sequence. It's also given in the formula booklet. You don't need to remember it. So you put A, the first one is 2, common ratio is 2, and you put down your calculator, it gives you 131070. And when you add all of them, it gives you that total of 131798. QED, quod erat demonstratum, as required to show. For 4 part 2, a sequence is defined by that on the top right there. So we start U1 is given 2 over 3. U1 is 2 over 3. Now we put n equals to 1. So that will give us U1 plus 1, which will give us U2. 1 plus 1 will give us 2. So that would be 1 over U1 because UN. 1 over U1. But since U1 is 2 over 3, we put 2 over 3 in there. So 1 divided by 2 over 3, it gives you 3 over 2. So that means U2 is 3 over 2. U1 is 2 over 3. Now we put n equals to 2. So 3 would be 2 plus 1 is 3. And it will be 1 over U2. So 1 over 3 over 2 will gives you 2 over 3. So we want to find the value from r equals to 1 to 100. So we have, it will be U1 plus U2 plus U3 plus U4 up to U100. We can add them. It goes 2 over 3 plus 3 over 2 plus 2 over 3 plus 3 over 2. We can do that until we get to 100. 100 term. What we can do is we can count them. We will see that how many 2 over 3 will be there. There's 2 over 3, skip, another 2 over 3, skip, another 2 over 3, skip, another 2 over 3. So there'll be 50 of them. So 2 over 3, 2 over 3, there'll be 50 of them because out of 150 of them. How many 3 over 2? 3 over 2, skip 3 over 2, skip 3 over 2. There'll be 50, 3 over 2. Because 50 plus 50 is 100. So we just multiply 50 times 2 over 3 plus 50 times 3 over 2. So what we are doing, we are counting the number of 2 over 3 and 3 over 2. And to do that, you put 50 is a factor. You take it out of the bracket. And you have 2 over 3 plus 3 over 2. Together, you get 325 over 3, which is 108 and 1/3 or 108.3 recurring. Question number 5. The equation 2x cubed plus x squared minus 1 equals to 0 has exactly one real root. We want to show that xn plus 1 is equals to that. So for question 5a, we were going to use this formula. Xn plus 1 is equals to xn minus f xn over f dash xn. So what we want to do is we have xn, we can write it as x subscript n divided by 1. And then we would have fxn is 2 xn cubed plus xn squared minus 1 divided by 6. How did we get 6? This f dash means we differentiate f of x. So 3 times 2 is 6, and then you minus 1 from the power. So 6x squared n. 2 times x minus 1 will be 2x and then n. And then when you differentiate minus 1, you get 0. So we want to add these two fractions together. these two fractions we want to put together. So the common denominator is 6. The lowest common multiple is 6xn squared plus 2xn. So that means xn times 6n squared plus 2xn minus that. So we remove the bracket. Xn times 6xn squared will be 6xn cubed. Xn times 2x will be 2x squared. And this will be minus 2x cubed minus 2x squared and plus 1. Remember, this minus and this minus will become a plus. Very important. That's where students make mistake. So what will happen now is the yellow one, 6x cubed minus 2x cubed will give you 4x cubed. And 2x squared minus x squared will give you x squared. And then you have that plus 1. And then you have the denominator. QED, quod erat demonstratum, as required to show. So for question 5b, using the formula given in part A, find the value of x2 and x3. So we want to go for x2. So we have 1 minus 2 times 1, 1, 1, 1. Substitute 1 there. That will give us x2 to be 3 over 4. And now, if we put n equals to 2, 2 plus 1 is 3. So that will give you x3 because n is 2. 2 plus 1 is 3. Now, so that would mean x2 minus 2x cubed plus x squared minus 1. Using that, we know x2 is 3 over 4. So we put 3 over 4 in there. 3 over 4 there. 3 over 4 there. And 3 over 4 in there. Put it all in your calculator. You get x3 to be 2 over 3. And what you can do in your calculator, after you have done the first one, don't delete it in your graphics calculator. All you do, you go and change the 1 to 3 over 4. You change 1 to 3 over 4 so that you get the answer. So wherever you see 1, you change it to 3 over 4. Change that 1 to 3 over 4. Change that 1 to 3 over 4. Change that 1 to 3 over 4. And that will give you your next answer. So it's quicker. Or you can just retype it all over again. So this is showing you a neater version of question 5b. x2 is 3 over 4 and x3 is 2 over 3. It's the same thing, but it's just been typed and done neatly. And for 5c, explain why for this question the Newton-Raphson method cannot be used with x1 equals to 0. When x1 is equals to 0, there is a stationary point at x equals to 0. So at x equals to 0, that point there, when x is 0, you come to the graph, there's a stationary point. So the tangent to the curve would not meet the x-axis. So you can see tangent does not exist, does not meet x-axis. So the tangent just goes straight across. So the tangent to the curve is horizontal. See that horizontal line there? So that's why you cannot use it. There's a stationary point at x equals to 0, and the tangent to the curve does not meet the x-axis or is horizontal. Question number 6. F of x is that. Calculate f of 2 and write f of x as a product of two algebraic factors. So we want to find f of 2. That means we're using the factor theorem to put f is of 2 means we substitute x is 2. So put 2 for x. So we put 2 for x, 2 for x, 2 for x. Put down your calculator, f of 2 is equals to 0. So when you do long division, what you do is you divide. I'll show you the way I remember it. It was very important. You divide, multiply, subtract, bring down, repeat. So divide, multiply, subtract, bring down, and then repeat. And the way to remember it is dead monkeys smell bad, and repeat. So we divide 3x cubed divided by x squared. So it's minus 3x cubed divided by x. That will give you minus 3x squared because one of the x would cancel. So that's number one. Number one is divide. So 3x cubed minus 3x cubed divided by x. You get minus 3x squared. So we've done number one, which is divide. Number two, we multiply. So if I call that 1, 2, 3, 4, 5. Number two is multiply. So we do minus 3x squared times x. It gives you minus 3x cubed. You write it directly under. Minus 3x squared times minus 2. It gives you plus 6x squared. Minus and minus gives you a plus. 3 times 2 gives you 6. And then there's an x squared. You write it under that. Now you subtract minus 3x cubed minus 3x cubed. Minus and minus becomes a plus. So become minus 3x cubed minus plus 3x cubed is 0. 8x squared minus 6x squared gives you 2x squared. And then number 4, you bring down the minus 9x. So number 4 is you bring down the minus 9x. Number 5, repeat. You go back to the top and start all over again. Number 1 is divide. 2x squared divided by x. So you write it 2x squared divided by x. One of the x will cancel and you're left with 2x. So the answer will be 2x. You go to number 2. Number 2 is multiply. 2x times x gives you 2x squared. 2x times minus 2, it gives you minus 4x. And the next thing is you subtract. 2x squared minus 2x squared is 0. Minus 9x minus 4x. Minus and minus becomes a plus. It becomes minus 9x plus 4x minus 5x. Number 4, you bring down the 10. Number 5, repeat. You start again. Minus 5x divided by x. It gives you minus 5. Minus 5x divided by x. The x would cancel. You're left with minus 5. Number 2, multiply. Minus 5 times x. It gives you minus 5x. Minus 5 times minus 2. It gives you plus 10. Number 3, you subtract. Minus 5x minus 5x is 0. 10 minus 10 is 0. So now you have the divisor, x minus 2. The quotient, minus 3x squared plus 2x minus 5. It's like saying 6 is the same as 2 times 3. 6 is the same as 2 times 3. So the 2 could be the divisor and the 3 could be the quotient. So part B, we have minus 3y to the power 6 plus 8y to the power 4, all of that. So we can have y squared minus 2 bracket minus 3y to the 4 plus 2y squared minus 5 equals to 0. So what we can have it as, it can be minus 3y squared all squared plus 2y squared minus 5. So that's like a disguised quadratic. So A is minus 3, B is 2, and C is minus 5. And we're using B squared minus 4AC. So it's 2 squared for B, minus 4 times A is minus 3. Minus 3 is from there, times C is minus 5 is less than 0. So you go minus 56 is less than 0. So it has no real solutions. So that's what we wanted to show. And if you put y squared minus 2 is equals to 0, y is equal to square root of 2. And square root of 2 is 2 answers. So there are 2 real solutions, plus square root of 2 and minus square root of 2. For part C, 3 tan cube theta minus 8 tan squared theta plus 9 tan theta minus 10 equal to 0. So there are 3 solutions. So if we have x equals to tan theta, so you can write it as 3x cubed. You replace tan theta with x, so that will be 3x cubed plus 8x squared plus 9x minus 10 equal to 0. And you can plot a graph where the minimum x is 7 pi, which will be 21.9, and the maximum x is 31.4, which is 10 pi, and y goes from minus 5 to 10. And if you look on the graphics calculator, you will see there's 3 solutions. Number one, number 2, and number 3. Those are the 3 points, 1, 2, 3. Those are the 3 points where it crosses the x-axis, and those are the 3 solutions. So this is part 6b written neatly, showing that it has no real solutions, and you use b squared minus 4ac, you get minus 56, and there are 2 answers, plus root 2 and minus root 2. Question 7. Solve for 0 less than x less than pi over 2 for sine x equals to sec x. So you want to change sec x and write it as 1 over cos x. And you take the cos x to the right hand to the left side, it becomes times. So it becomes 4 sine x cos x is equals to 1. 4 is the same as 2 times 2. So now the reason why we do that is because we would have 2 sine x cos x, and that reminds us of sine 2x. Like sine 2 theta is 2 sine theta cos theta. So we use this technique in math where you split the 4 into 2 times 2, and now we can write 2 sine x cos x as 2 sine 2x. The reason is we want to get them only into one type of trigonometric function to solve it. We cannot solve when we have sine and cos. So we change it to one thing that has only sine, and you could solve it. Now we have sine x. We take this 2 to the right hand side, it becomes divided by 2. So sine 2x equals to a half. So 2x will be inverse sine of a half. So 2x will be 30 degrees. And 30 degrees is the same as pi over 6. To change from degrees to radians, you multiply by pi over 180. So pi over 6. So x is pi over 6 divided by 2. Take the 2 to the right, it becomes divided by 2. So x is pi over 12. And also sine is positive in the second quadrant, which will be 5 pi over 12. That's pi minus pi over 6. Pi minus pi over 12 will give you the 5 pi over 12. So that may how you get the second answer. So those are the answers for x. For part 2, it says solve the equation 5 sine theta minus 5 cos theta equals to 2. So what we want to do, we want to write it as r sine theta minus alpha equals to 2. How do we find what r is? So we want to change it from the first form to the next form. So we need to find this r. How do we find r? We find 5 squared plus 5 squared and square root it. That'll give us square root of 50. Watch that the number there, 5 squared plus 5 squared, gives you the square root of 50. And the angle is tangent to alpha is 1. So alpha is 45 degrees. The tangent of 5 divided by 5. So we would have it as r is 50. The sine stays the same. Theta stays the same. Alpha is 45 and the 2 stays the same. Now we can solve it. So what we have done, this is where we start. This is where we end. So we have changed it to this form. Why did we change it? Because we can now solve this. It has only sine. Before it had sine and cosine. We cannot solve it when it has two of them mixed, sine and cosine. We want it to have only sine. So we change it from that to that. Now we can solve it. So we take square root of 50 to the right. It becomes divided by square root of 50. And then, so the angle is inverse sine of 2 over square root of 50. Take minus 45 to the right, add 45. So you will get your answers to be 61.4 degrees and 208.6 degrees. So that's the same working out, 61.4 and 208. This is written neatly. Question number 8. Figure 1 is a graph showing the trajectory of a rugby ball. Part A, find a quadratic equation linking h with x that models this situation. So if you look at the graph, we have 0, 0 is a start origin. 40, 0 is the point at the end there, 40, 0. We have 0, 0. And in the middle, we have 20. And the maximum height is 12. We have 20, 12, and this height is 12. We want to find a quadratic equation linking h and x. So we write a quadratic equation as ax squared plus bx plus c. That's general form of a quadratic equation. Now, we know when x is 0, h is 0. So we substitute h is 0 and x is 0. So that'll give us 0 is equals to a times 0 plus b times 0 plus c. That means c is equals to 0. It also tells us when h is 40, when x is 40, h is 0. So we put h to be 0 and x to be 40. And we'll get 1600a squared plus 40b is equal to 0. And when x is 20, h is 12. So we'll have 12 for h, and then x is 20 squared plus 20b. That gives us 400a plus 20b equal to 12. So we call that equation 1, call that equation 2. And we can solve the two simultaneous equations using your graphics calculator. And you will get a to be minus 0.03 and b to be 1.2. So now you can write it as h is equals to minus 0.03 for a at x squared plus b is 12 and our c is 0. So that's your quadratic equation there. Or you can write it like this, because 0.03 is the same as 3 over 100. This is the same as 3 divided by 100. And or you can write it like that. So there are 3 different ways you can write the answer. For part B, h is equals to 3 meters. So if we put 3 in there, it's equals to minus 0.03 x squared plus 12x. You can use equation solver in your calculator to check this answer if it's correct, to solve this equation. But don't just write that answer, because you wouldn't get full marks. You need to show you're working. So you can solve this as a quadratic. Take the minus 0.03 x squared plus 12x. You take the 3 to this side, it becomes minus 3 equal to 0. Put that in your calculator. You will get x to be 20 plus 10 root 3, which is 37.3 meters. And x is 20 minus 10 root 3. So we find x as it is the horizontal distance. So for part C, the ground is horizontal. The ball needs to be kicked from the ground. The ball is modeled as a particle. No wind or air resistance on the ball. No spin on the ball. Trajectory is perfect parabola. Perfect parabola. And no spinning in the air of the ball. There's no air resistance. Those are some of the reasons. So that's question 8C written neatly. So the answers that were acceptable are: the ground is horizontal, the ball needs to be kicked from the ground, model as a particle, no wind or air resistance, no spinning of the ball, no obstacles, the trajectory of the ball is a perfect parabola, that shape. Question number 9. Given that theta is measured in radians, prove from first principles that differential of cos theta is equal to minus sine theta. So f of x is cos theta. So we want to differentiate cos theta. So we're using this formula there. That's very important. I've circled it. F dash of x is given as the limit as h tends to 0. F of x plus h. Remember, we've added h to it. Just f of x plus h minus f of x divided by h. So f of x is cos theta. So we'll have cos theta plus the h, theta plus h, minus f of x, which is cos theta, divided by h. But cos theta plus h, you would use the addition formula to expand it. It will be cos theta cos h minus sine theta sine h. So we've expanded this to this. That's very important. We expand this to this. And then the cos theta stays the same. Now we've been given some assumptions in the thing. So what we want to do, we factorize this. We can separate them and then we can factorize. So we can have cos theta bracket cos h minus 1 over h. So we're taking this 1, 2, 3. So we factorize cos theta out. It comes out of the bracket. We have cos x h and then minus 1 there divided by h. Minus, we can have sine theta sine h divided by h. So all of this, we put it as 1. But we are told that sine h over h tends to 1. As h tends to 0, sine h, this one tends to 1. And cos h minus 1 tends to 0. So this one tends to 0. So this will be cos theta times 0. All of this will be 0. All of this will be 1. So all of this will become 0. Cos theta times 0 is 0. Minus sine theta times 1, it gives you minus sine theta. So that's question 9, written neatly. Cos theta plus h minus cos theta, and you change it to that, and then you factorize that out, separate them, and it's all written neatly. So differential of cos theta, when you differentiate cos theta, you get minus sine theta. Question number 10. A spherical mint of radius 5 millimeter is placed in the mouth and sucked. 4 minutes later, the radius of the mint is 3 millimeters. Using this model and the information part A, find an equation linking the radius of the mint and the time. You should define the variables that you use. So we have dr over dt is proportional to minus 1 over r squared. And we do it by separate the variables and integrate. So what we want to do, we remove the proportional sign, replace it with minus k. So remove the proportional sign and replace it with minus k. And to separate the variables, we'll take r squared to the left, so it becomes r squared dr. And then take dt to the right, it becomes minus k dt. And we integrate both sides. So integral of r squared dr is equals to integral of minus k dt. So separate the variables and integrate. When you integrate, you add 1 to the power, divide by the new power. So it becomes r cubed over 3. And since k is a constant, when you integrate minus k, you just get minus kt plus c. And we need to find c. C is a constant of integration. And we know at the start t is equals to 0, r is equals to 5 millimeters. And when t is equals to 4 minutes, r equals to 3 millimeters. So we're going to do it using the time in seconds. T is equals to 0, r equals to 5 millimeters. So we got r cubed over 3 is equals to minus kt plus 125 over 3. So 3 cubed over 3 is equals to minus k times 240 plus 125. 240 comes from 60 times 4. 60 times 4 is 240. And the radius is 3 millimeters. So 3 millimeters and the 240. And you will solve that. That will give you k to be 49 over 360. So it's 49 over 360. So r is the radius of the mint in millimeters. T is the time in seconds from when the mint was placed in the mouth. Time in seconds from when you place the mint in your mouth. And the k is 49 over 360. And this is how we got c. When r is 5, t is 0. So minus k times 0 will be 0. And 5 cubed is 125. So c is 125 over 3. That's how we got c to be 125 over 3. For 10b, find the total time taken for the mint to completely dissolve. So that's the equation there. When it's completely dissolved, r is equal to 0. It doesn't exist. If that's the circle there and the radius, when the radius is 0, it doesn't exist. It's completely dissolved. So you put r to be 0. So all of this left will be 0. You take minus 49 over 6 to the right. It becomes 49t over 6 equals to 125 over 3. So t would be 125 over 3 divided by 49 over 6. And that will give you 250 over 49 minutes, 5.102 minutes. And we want to change it to seconds. We want to change 0.102 to seconds. So we multiply 0.102 times 60. It gives you 6.122 seconds. So it will be 5 minutes and 6 seconds. So that's questions 10A, B, and C written neatly. 10A is written neatly there. 10B is given 5 minutes and 6 seconds neatly. And 10C gives you all the suitable reasons. Model does not consider how the mint is sucked. Some people suck faster and slower. Model does not consider whether the mint is beaten. Model is limited for times up to 5 minutes and 6 seconds. These are all examples of suitable limitations.